In this tutorial, I'm going to show you how to complete the square for x squared minus 6x plus 5. This is the graph of the equation. If I use tiles to solve this equation, I would have to add 4 more tiles, in this case gray tiles, to complete the square. When we complete the square, or even the term completing the square, that's what it's referencing. I'm not going to use tiles. I'm going to use the classic manner, what you probably see in your classes. The first thing I do is move 5 to the other side of the equation. I want to isolate x squared minus 6x. So I subtract 5 from both sides of the equation. Those two 5's cancel out, which gives me x squared minus 6x is equal to negative 5. Now I can complete the square. And I'm going to focus in on the 6. So I take 1/2 times 6, which is equal to 3. And then I take that 3 and I square it, which gives me 9. Now I add 9 to both sides of the equation. What I do to one side, I have to do the other. Now I have x squared minus 6 plus 9 is equal to 4. So now I actually have a new equation that's different from my first equation. Let me show this to you graphically. This is the equation I started with. X squared minus 6x plus 5 is equal to 0. When I completed the square, I got a new equation. I took my first equation and added 4. 1, 2, 3, 4. Remember the tiles I talked about initially, those 4 gray ones right there? Adding 4 to complete the square. So that's what I did. I added 4 to the equation to complete the square. The first equation is set equal to 0, that dashed line right here. Now the second equation I have set equal to 4. So the line shifts up. I'm going to solve where the equation equals to 4, or y is equal to 4. And it turns out the x values for the solutions to that first equation or the second equation, the x values are actually the same. Y is different, but x is the same. So now I have factors x minus 3 times x minus 3. And this is equal to 4. Let's bring the 4 down. Equal to 4. And it turns out that 3 and that 3 are basically the same. So I have x minus 3 squared is equal to 4. If I take the square root of both sides, I end up with x minus 3 is equal to plus or minus 2. And now I can solve for x, or isolate x, get x all by itself. So I have two equations, x minus 3 is equal to positive 2, and x minus 3 is equal to negative 2. So I add 3 to both sides of the equation to isolate the x, so the 3's cancel out, and I have x is equal to 5. I add 3 to this equation too, both sides of the equation, so I have the 3's cancel. I have x is equal to 1. And this turns out to be the solution to the equation. And it turns out to be the solution to our very first equation. Where does that purple line cross the x-axis? And it crosses at 1, and it crosses at 5. So if you plug those numbers into x squared minus 6x plus 5, you'd get 0 as well. The next problem I'm going to do is 2x squared plus 4x minus 6. And the important thing is what happens when that first value is not 1. In this case, it's going to be 2. And you can move to that next video by clicking on the playlist or clicking next.